In this question from CSIR NET December 2024, we have an ideal Bose gas. Its density of states is given by rho of E is equal to CE square. It is given that number of bosons is not conserved. This means chemical potential is equal to 0, as number of bosons is not conserved. Now we are asked the variation of specific heat of the gas with temperature T. We know that specific heat, it is the derivative of total energy U with respect to T. Now total energy U is given by U is equal to integral 0 to infinity E times rho of E. Rho of E is the density of states times f of E. F of E is the distribution function times dE. Here distribution function for ideal Bose gas is Bose-Einstein distribution function, which is 1 divided by e raised to E minus mu divided by kT minus 1. Mu is equal to 0, so f of E becomes 1 by e raised to E by kT minus 1. This is the distribution function. Therefore U becomes, U is equal to integral 0 to infinity E times f of E is 1 by e raised to E by kT minus 1 times rho of E is CE square dE. There is no need to solve this integral completely. We only need the proportionality of U with T. Therefore we can put E by kT is equal to X. Let E by kT is equal to X. This implies E is equal to X kT and dE is equal to kT dx. When E is equal to 0, X equal to 0. When E is equal to infinity, X equal to infinity. So there is no change in the limits. So the integral becomes U is equal to integral 0 to infinity. Instead of E, put X kT. Then we have 1 by e raised to X minus 1. C times E square is X kT the whole square, and instead of dE we have kT dx. kT dx. Therefore we have U is equal to C T raised to 4 K raised to 4 integral 0 to infinity X cube divided by e raised to X minus 1 dx. This quantity, this integral, it is not depending on T, it is just a number. If you integrate it, you will get some number. Therefore we can write U is proportional to T raised to 4. Actually this number is equal to pi raised to 4 divided by 15. This we are familiar with from Bose theory. In Bose theory we have some integral like this. But it's not necessary to know its value, it is just some number. So the proportionality is U is proportional to T raised to 4. Now CV is equal to del U upon del T. Therefore CV is proportional to T raised to 4 minus 1. 1 power will decrease when we take derivative with respect to temperature. So CV is proportional to T cube. The correct option here is option 2.